Hi and welcome back. So in the past video we had been talking about the atom, and as an example I gave you this helium atom, and what we were talking about was how the atom has got three different, or for our purposes I guess, the atom has got three different particles that comprise the atom. And those are electrons, which, if you remember from the last video, are just going to be pretty much represented by this haze. And it's really a probability function of where we might find an electron in this haze, saying that we have a greater probability of finding it closer to the center of the atom than farther away. And then we also had this nucleus in the atom, and inside the nucleus, the nucleus of our atom was comprised of protons, which had a positive charge, and neutrons which had no charge. And then also the electrons that made up this haze had a negative charge, and so therefore the electrons having a negative charge and the protons in the nucleus having a positive charge was what sort of kept the electrons around the nucleus. What that was the attraction for these electrons. Instead of to fly away into space, the attraction was for the electrons to stick around the nucleus of this atom. And in the last video I told you that the nucleus occupies only 1/10,000th of the space of what we consider the atom. And even to call it the space that we consider an atom, you can see that it's almost a bit of a stretch to say that an atom has a definite space, because it's really just a probability of where we're going to find this electron, because there are so many different possible places where this electron could actually be. But in terms of where that electron could actually be, and again the probability of where we could find that electron, the nucleus is only 1/10,000th of that space, and it's only 1/10,000th of the space that we consider to be the actual atom. But again, and I told you this in the last video, that this nucleus contains most of the mass of the atom. And now, I guess to continue on that, I'm actually going to throw out some numbers, and we're going to try to figure out exactly how much mass. And I'm also going to introduce you to maybe a new concept, the concept of the atomic mass unit. So to start off with, remember we have protons. So we have protons, and they're in the nucleus. We have, excuse me, we have neutrons, which are also in the nucleus along with the protons. And then floating around in this haze are the electrons. And so now the proton, let's start off with the mass of the proton. The proton has a mass of 1.672 times 10 to the minus 24 grams. So it's a very small amount of mass. It's 1.67 times 10 to the minus 24. It's really almost inconceivably tiny, the amount of mass that one proton takes up. A neutron takes up a very similar amount of mass. A neutron takes up 1.675 times 10 to the minus 24 grams. So a neutron, there's not, even down at this stage, there's not a lot of variation between the mass of a proton and the mass of a neutron. And for even, we'll definitely see when we start talking about isotopes in this playlist that we're really going to consider the mass of a proton and the mass of a neutron to be essentially the same. We're going to consider them to have the same exact mass. But for right now, this is essentially the mass of a proton is 1.672 times 10 to the minus 24 grams, and the mass of a neutron is 1.675 times 10 to the minus 24 grams. And finally, we have the electron, and the electron has a mass that is much, much smaller. The electron has a mass of 9.109 times 10 to the minus 28th grams. So this, and you know, it might not seem so incredibly tiny, but you know, you have to remember that we are, you know, this is 4 more decimal places. So this is going to be 1/10,000th the mass. Even though in scientific notation it makes it look like, you know, there's not as much variation between the masses of these 3 different particles than there actually is. But this amount, comparing something to the -24th power, comparing the electron to something which is something to the -28th power, it's a very significant amount of variation. So let's actually try to figure out. I told you that the nucleus occupies most of the mass of this helium atom, and this is a little bit. We'll definitely get into more on isotopes in the future, but essentially for this we're going to deal with an isotope of hydrogen or of helium, and this isotope is going to have 2 neutrons. And we'll definitely go into this more in the future. It's going to have two neutrons. It's going to our atom, and essentially what determines what type of atom we're looking at is the number of protons in that atom. And helium, any helium atom, is always going to have 2 protons. And again, I'll definitely give you much more on that information in the future. Right now, I just want to show you how much of the mass of an atom is actually located in the nucleus. So we're going to have 2 protons. In this isotope, we will have 2 neutrons. And then finally, remember that a proton essentially has a +1 atomic charge, and an electron has a -1 atomic charge. So we are going to have this be a neutral atom. So we are going to have 2 electrons. So let's try to figure out how much mass would actually be in the entire nucleus versus how much mass would be in the entire atom. So we could say that this is going to be, and you can see that these might be kind of messy numbers, but we are going to have 2 protons. So we could say that we'll have, and I'll change colors here. So we are going to have 2 times 1.672 times 10 to the -24th. And then we are going to add that to our 2 neutrons. So we are going to have 2 neutrons, and their mass is 1.675 times 10 to the -24th. And then we are going to have 2 electrons. So or actually, you know what, for this we're just going to figure out the mass of our nucleus, which is going to be on the top of our fraction, and we're going to divide that by the mass of the entire atom. So we can figure out just how much or what percentage of our mass is going to be located in the nucleus. So again, we've got the same factor. We've got 2 times 1.672 times 10 to the -24. Those are our protons. And then we're going to add the mass of our neutrons, which is 2 times 1.675 times 10 to the -24th. So this is going to be the mass of our neutrons. And then finally, we're going to add in the mass of our electrons. So we're going to add to that our 2. We have 2 electrons, so we have 2 times 9.109 times 10 to the -28th grams. And now I'm going to get out the calculator. My calculator might actually have some trouble dealing with numbers that are this small. I actually tried to do this earlier. If it does have trouble, I'll stop the video and maybe just figure it out with a different calculator. And try to, I guess, anyway, let's just try this out and see if this actually works. So we are going to have 2 times 1.672, so that's 3.34, and then we're going to raise that times 10 to the -24, And then we're going to add that to 2 times 1.675 times 10 raised to the minus 24th power. And I've got a feeling this actually isn't going to work very well with this calculator. You know what? I'm going to stop the video here, and I'm going to try to maybe work this out a little bit better algebraically, so maybe we won't have to do all the scientific notation in the calculator, or else I'll just do this. I've got a calculator with me that handles scientific notation a little bit better. But anyway, I'm actually going to stop the video here, and I'll see you in a future video.